Okay, today we want to talk about how to focus a paper that's related to a bunch of disorganized data, how to focus it in a way that you can sell the paper. And the thing started with, we had the BXD2, we knew IL-17 signal to NF-kappa B and RGS. But the problem is, and we had the IL-17 receptor knockout, we knew a lot about it. Terminal centers were low, marginal zone was high. But the other thing that was out there was P50 was high in the IL-17 receptor knockout. So then the question becomes, well, we're going to study P50, and we did a lot of experiments, and P50 signaling, P50 may inhibit signaling of genes. We showed that, and then we also, on the other hand, showed that IL-17 receptor signaled some genes. So we got the idea, well, NF-kappa B signals, P50 blocks, we get the idea that NF-kappa B and P50 are sort of like master switches inside the B cell, and it started through IL-17 receptor. Now the problem is we get this hodgepodge of data, all related to NF-kappa B and P50, but we don't have a P50 knockout. We don't have a good way to manipulate the NF-kappa B except for that PP60, that inhibitory peptide. So the paper could read, what is NF-kappa B signaling P50 regulate germinal center and marginal zone development in BXD2 mice. Now the problem is, what one would expect to do is start to manipulate, upregulate and downregulate P50 in sort of a direct confirmatory way. Well, we didn't do that. So we always backed into that corner. So instead of doing that, jump right into the middle of what gave us the idea to begin with, and that was the IL-17 receptor knockout mice. And then you just study IL-17 receptor intact mice, signaling P50, IL-17 receptor knockout mice, signaling P50 development, and you come up with the following title. IL-17 receptor is essential for germinal center B cell development. And then everything will be, then the beginning experiments is through IL-17 receptor, and you see the big germinal center B cells and small marginal zone. We already published that. Then you go to things, the tools we have, which is add IL-17 receptor FC and add IL-17, manipulated in vitro, in vivo, inside the mouse. And you show that IL-17 receptor does more than just, upregulate RGS16 and upregulate germinal center. It does different things. I think it sort of increases the marginal zone. It actually increases P50 if you block IL-17. There was an in vivo experiment, we did that. So we have this sort of first step, the discovery phase, this beginning of the confirmatory phase, and we have the IL-17 receptor knockout BXD2 mice. So this is step 2. And this I put as a confirmatory phase. You always like to say, okay, to further show that IL-17 receptor is essential, we studied the knockout. We took that gene out. And then we know how that goes. The P50, that's where, wow, P50 is very high, so then the genes are different. So that's how to make this paper, how to make a paper about P50, which we don't have much data for, or BCL6, which was the other thing we didn't have much data for, how they do it. We have some data, back it up and say it's really IL-17 receptor without IL-17 receptor and IL-17 receptor signaling that steers, the regulation of NF-kappa B, P50, and BCL6. And it'll be a closed story that's very complete about the role of IL-17 receptor in germinal center B cell development.